NENOMATICA, where mathematics meets YouTube excellence. In this example, we will follow a clean, step-by-step path to solve the problem exactly as written in the provided solution. Example: which positive number satisfies open parenthesis 1/3 x plus 1 close parenthesis times open parenthesis 1/4 x plus 1 close parenthesis equals 20? Step 1. Let the number be x. Step 2. Write the equation exactly as given. Step 3. Expand the product using the distributive property. Step 4. Clear the fractions by multiplying both sides by 12. Step 5. Now simplify. Step 6. Combine like terms and move everything to one side. Step 7. Factor the quadratic. 19 minus 12 equals 7, and 19 times negative 12 equals negative 228. So it factors as open parenthesis x plus 19 close parenthesis times open parenthesis x minus 12 close parenthesis equals 0. Step 8. Set each factor equal to 0 to get the roots. The problem asks for the positive number, so the answer is x equals 12. Recap: we expanded, cleared fractions, simplified to a quadratic, factored, found both roots, and selected the positive one. The positive solution is 12. In this example, we will find 3 consecutive numbers that satisfy a special property, that the square of the middle one is exactly one more than the product of the other two. Problem: find 3 consecutive numbers so that the square of the middle number is one more than the product of the other two numbers. Let the first number be x. Then the 3 consecutive numbers are x, x plus 1, and x plus 2. We will place them on a simple number line to anchor the idea of consecutive spacing. According to the statement, the square of the middle number equals one more than the product of the other two. That translates directly into the equation open parenthesis x plus 1 close parenthesis squared equals x times x plus 2 plus 1. Now expand both sides. The left side, x plus 1 squared, becomes x squared plus 2x plus 1. The right side, x times x plus 2, becomes x squared plus 2x, and then we add 1. So both sides simplify to exactly the same expression. Because both sides reduce to the same expression, this equation is an identity. It holds for every value of x. That means any 3 consecutive numbers will satisfy the property. Let us verify with a concrete example. Choose 17, 18, and 19. The square of 18 is 324. The product of 17 and 19 is 323, and adding 1 gives 324, which matches perfectly. Here is the same idea written in a single line. Open parenthesis north plus 1 close parenthesis squared minus n times n plus 2 equals 1. This proves the identity for all integers n. Final answer: any 3 consecutive numbers satisfy the condition. The square of the middle number equals one more than the product of the other two. Welcome! In this example, we will solve for 2 consecutive odd integers, whose squares add up to 290 following a clean, step-by-step structure. Here is the example, then the precise algebraic setup using k to represent odd integers. Step 1. Write the equation for the sum of the squares. Step 2. Expand each square using the binomial pattern of plus b squared equals a squared plus 2ab plus b squared. Step 3. Combine like terms and move everything to one side. Step 4. Factor out the greatest common factor 8. Step 5. Factor the quadratic. We look for 2 numbers that multiply to negative 35 and add to 2, 7 and negative 5. So it factors as k plus 7 times k minus 5. Step 6. Apply the zero product property. Set each factor to 0 to find k equals negative 7 or k equals 5. Step 7. Find k equals negative 7 or k equals 5. Step 7. Substitute k equals negative 7 back into the expressions 2k plus 1 and 2k plus 3 to get negative 13 and negative 11. Step 8. Substitute k equals 5. The numbers are 11 and 13. Quick check. 11 squared plus 13 squared equals 121 plus 169, which is 290. Likewise, negative 13 squared plus negative 11 squared also equals 290. Final answer: the consecutive odd integers are negative 13 and negative 11, or 11 and 13. Example: we will solve a classic age puzzle step by step. A teacher says 21 years from now, my age will equal the square of my age 21 years ago. What is the teacher's current age? Step 1. Define the variable. Let x be the teacher's current age. Translate the sentence directly into an equation. 21 years from now is x plus 21. 21 years ago is x minus 21. And squaring that gives the right side. Step 2. Expand the square and simplify. Using the binomial square, a minus b quantity squared equals a squared minus 2a b plus b squared. Now move all terms to one side to make a standard quadratic. Step 3. Factor the quadratic. We look for two numbers that multiply to 420 and add to negative 43. Those are negative 28 and negative 15. Set each factor equal to 0. Step 4. Apply a reality check. Ages cannot be negative. 21 years ago, the age must be positive. That means x minus 21 is greater than 0. So x must be greater than 21. Therefore, x must be greater than 21. Therefore, x equals 28 is acceptable, while x equals 15 would imply a negative age 21 years ago, and is rejected. Step 5. Verify the accepted solution by substitution. Substitute x equals 28 into the original equation. Left side is 28 plus 21, which is 49. Right side is 28 minus 21 squared, which is 7 squared, also 49. The equation holds. Also 49. The equation holds. In this example, we will determine two natural numbers. One number is 10 larger than the other. A mistaken product is reported. And when that mistaken product is divided by the smaller number, the quotient is 39 with remainder 22. The correct product is 40 more than the mistaken one. Let's find the numbers. Let the smaller number be x, and the larger number be x plus 10. We'll sketch this relationship on a number line to keep the 10-unit gap visual. Now for the information about the mistaken product. Dividing the mistaken product by the smaller number x gives a quotient of 39 and a remainder of 22. In algebra, that means mistaken equals 39x plus 22. The true product should be x times x plus 10. And we are told the correct product is 40 more than the mistaken one. So x times x plus 10 equals mistaken plus 40. Let's expand and simplify. X times x plus 10 becomes x squared plus 10x. On the right, 22 plus 40 is 62. Move everything to one side. We factor the quadratic. Numbers that multiply to negative 62 and add to negative 29 are negative 31 and 2. So the quadratic factors as x minus 31 times x plus 2 equals 0. The solutions are x equals 31 or x equals negative 2. We keep the natural number x equals 31. The larger number is x plus 10, which is 41. Let's verify the 40 difference claim. The true product is 31 times 41 equals 1,271. The mistaken amount was 39x plus 22, which is 39 times 31 plus 22 equals 1,231. The difference is exactly 40, as stated. 39x plus 22, which is 39 times 31 plus 22 equals 1,231. The difference is exactly 40, as stated. In this lesson, we solve a classic algebra word problem using a clear diagram and step-by-step equations. We are told, Mr. Ahmad bought several identical toys for a kindergarten. The total money spent was $12,000. If the seller discounted $100 on each toy, he could have bought 4 more toys with the same total money. Find the original price per toy, and then the number of toys. Let's build a visual. On the left, the original purchase. Price per toy is X dollars, and number of toys is Y. On the right, the discounted purchase. Price per toy is X minus 100, and number of toys is Y plus 4. Both totals equal $12,000. From the original receipt, the total is price times quantity X times Y equals 12,000. From the discounted receipt, we get quantity y plus 4 at price x minus 100, still totaling 12,000. These are our two equations. First, solve the first equation for y. That gives y equals 12,000 over x. Now substitute that into the second equation. Combine the terms inside the parentheses, then multiply both sides by x to clear the denominator. Next, expand and simplify. Subtract 12,000x from both sides, gather like terms, and then divide by 4 to simplify. We obtain a clean quadratic equation. Now factor. We look for two numbers that multiply to negative 300,000 and add to negative 100. Those numbers are negative 600 and positive 500. So the quadratic factors into left parenthesis x minus 600 right parenthesis times left parenthesis x plus 500 right parenthesis equals 0. The possible roots are x equals 600 and x equals negative 500. Price cannot be negative, so the valid price per toy is $600. Finally, compute the number of toys using y equals 12,000 over x. With x equal to 600, y equals 20 toys. Answer: the original price per toy is $600, and Mr. Ahmad bought 20 toys. Great work! Example with two positive integers and four operations leading to a sum of 243. We have two positive integers, x the larger and y the smaller. Perform four operations. 1. The sum x plus y. 2. The difference x minus y. 3. The product x, y. 4. The quotient x divided by y. The sum of these four results equals 243. Find x and y. Let's visualize the four pieces so the structure is clear. Translating the sentence into an equation gives exactly left parenthesis x plus y right parenthesis plus left parenthesis x minus y right parenthesis plus xy plus x over y equals 243. Because x and y are integers, and y is positive, multiply the entire equation by y to clear the denominator. Now distribute and simplify. The y squared terms cancel. Factor out x on the left. Notice that 2y plus y squared plus 1 equals y squared plus 2y plus 1, which is y plus 1 quantity squared. Solve for x in terms of y. Because y and y plus 1 are consecutive, they are coprime. Therefore, y is coprime with the square of y plus 1. For x to be an integer, the square of y plus 1 must divide 243. Factor 243 as 3 to the 5th power. The perfect square divisors are 1, 3 squared, and 3 to the 4th power. That means the square of y plus 1 can be 1, 9, or 81. Solve for y from each option and keep y positive. Now compute x using the formula. For y equals 2, x equals 54. For y equals 8, x equals 24. Let's quickly verify one pair in the original expression to build confidence. Therefore, the two positive integer solutions are x equals 54 with y equals 2, or x equals 24 with y equals 8. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.